Hello guys. Guys, am I audible to you? Please mark your attendance and confirm once to those who can see me and hear me. Confirm once if I'm audible to you. Hello guys. Is anyone there? Oh, hi Tanago. How are you guys? Please confirm once. Am I audible and visible to you? Okay, so guys, let's begin with the topic. Okay. In the last class, we have discussed about the Lewis theory. Its drawback also we have covered in the last class. Now we have to discuss the new theory. Ultimately, we have seen in the Lewis theory that that says that how chemical bond can exist. Means for the existence of a chemical bond, there must be 8 electrons in the valence shell. Okay. But this theory doesn't give any idea regarding the situation that how bonds can form. Okay. What should be the conditions? Even we have no information regarding the shapes and what should be arrangement of atoms. So there were lots of exceptions over there as well. One of the exception was that odd electron molecules. Okay. So guys, to overcome all those exceptions or the drawbacks, we have to discuss few more theories that will clear our concepts and will help us to understand more about the molecules. Okay. So guys, after that, we have to discuss about the valence bond theory. Valence bond theory. Please do not copy it. You have to just look at the screen and understand the meaning first. Guys, valence bond theory gives us idea that how bonds can form. Okay. First of all, let's discuss its phenomena that how bonds can form. See, it says that let's suppose we have got two atoms. Okay. I'm talking about the specifically hydrogen right now. Let's talk about the hydrogen first. See, this is one atom of the hydrogen, contains one electron. Okay. Spin is anti-clockwise right now. This is another atom of hydrogen and its spin is clockwise. Okay. This is another atom of the hydrogen. Guys, right now these two hydrogen atoms are at infinite distance. Okay. So when they are present at the infinite distance, we know that there can never be any force of attraction or repulsion between the two atoms. Okay. But whenever they will come close to each other, new forces will start acting on them. Okay. Right now, they are at infinite distance. Okay. They will start approaching each other. Now, when they come closer to each other, when they come close to each other, I'm talking about this situation. This is the electron. There is also electron. Okay. So guys, when they come close to each other, new forces will start acting on them. Okay. If I talk about the attractive force that will act, see, this is hydrogen atom A, this is hydrogen atom B. We know that attractive force can act only when there is opposite charges. Okay. So I can say that the nucleus has got the positive charge, whereas the electron gets the negative charge. So when we talk about the attractive forces, guys, the atom of A means the nucleus of atom A and between the electron of atom B, there will be attractive force. And between nucleus of B and electron of A will again have the attractive force because they are oppositely charged. Yeah, obviously there is also old attractive force is acting on them. Which one? Between its own nucleus and the electron. But I'm talking about the new forces that will start acting on each other whenever they come close enough to each other. So these are the attractive forces. When I talk about the repulsive forces, what repulsive force can act over there? Guys, We know that electron has got the negative charge, nucleus has got the positive charge. So electrons, as we know, have the same charges. So there is repulsive force between the electrons, and there is repulsive force between the nucleus of A and B. So after understanding the concept of forces, let's write down them. New forces. First is attractive forces. Attractive force will be between nucleus of A, electron of B, and nucleus of B, electron of A. Okay. If I talk about repulsive force, between nucleus of A, nucleus of B, and electron of A, electron of B. These are, guys, new attractive and repulsive forces. Okay. Now, the situation is how bond will be formed. Okay. Guys, valence bond theory says that a chemical bond will be formed by the overlapping of atomic orbitals. I'm repeating again. That chemical bond is formed by the overlapping of atomic orbitals. See, when both hydrogen atoms overlaps with each other, this common region is known as attractive force or a bond. Okay, try to understand it. That this common region where two atomic orbitals have overlapped each other, okay, is known as the chemical bond. Okay, valence bond theory says that for the formation of a chemical bond, it is necessary to overlap atomic orbitals, and the atomic orbitals which are overlapping with each other must contain the electrons, with the opposite spin. Means, if you remember, see, I was saying that the electron of atom A is moving in the anti-clockwise direction, whereas electron of atom B is moving in the clockwise direction. It means that spin of both the electrons is opposite. So this theory says that to form a chemical bond, atomic orbitals should have the electrons, and they must possess the opposite spin. Okay, if this condition satisfied, they will overlap with each other, and the whole overlapping region will be known as your chemical bond. Higher is the extent of overlapping, stronger will be the bond. Okay, I'm saying that higher is the overlapping region, stronger will be the bond. Important thing, that up to how much section, or we can say how much region will they overlap, in how much region they will overlap. Okay, guys, see, when I was talking about the new forces, attractive forces as well as repulsive forces. Okay, if I ask you, between attractive and repulsive forces, if atoms are coming closer to each other, then which force should dominate? Attractive force or the repulsive force? I am repeating that when atoms are coming closer to each other, both type of forces are acting over there, attractive force as well as repulsive force, and still atoms are coming closer to each other, then what should be the dominating force? Attractive force or the repulsive force? Itanaga, are you there? Okay, yeah, obviously attractive force will dominate because still atoms are coming closer to each other. Okay. Now, the situation I was asking that up to what reason they will come closer to each other. Guys, see, when atoms are coming closer to each other, attractive force is definitely dominating, but along with that, repulsive force is also operating over there. So when they will come close to each other, obviously, whenever they will come more closer to each other, repulsive force will also start dominating. Means the magnitude of the repulsive force will also be higher when they will be much closer to each other. See, if I talk you about this one, first scenario is this one. Okay. If I ask you about the repulsive force, definitely it won't be very much. But if I ask you about this scenario where atoms are quite closer to each other, obviously the repulsive force will be relatively high as I compared in the case number 1. Okay. So guys, when a chemical bond is formed at that scenario, or we can say at that point, equilibrium is established. Equilibrium means their attractive force are net balanced by the repulsive force. Means now atoms are fixed at some particular position where neither they can move away from each other, nor they can come much more closer to each other. Okay. If this situation reaches, if this state of equilibrium reaches over there, we will say it is a bonded state. Are you getting my point? That this is known as the bonded state. Okay. So guys, make it clear that when a chemical bond is formed, at that time, net attractive force are exactly balanced by the net repulsive force. Okay. This is all has been discussed in the valence bond theory. Valence bond, if I summarize the valence bond theory, it simply says that for the formation of a chemical bond, atomic orbitals overlap with each other, containing the electrons with the opposite spin. Okay. Second thing, it says that the strength of the bonds depends on the extent of overlapping. Means, if I talk you about the two scenarios, look at this and this one. Obviously, in the second case, the extent of overlapping region is high. That's why this bond is more stronger. Okay. So higher is the overlapping, greater will be the bond strength. Okay. So valence bond theory has given this idea that how chemical bonds can be formed. Okay. So guys, I am drawing a graph for this one. Remember, I'll write it everything that I have discussed with you. Okay. But first of all, let's understand this one. See, these are atoms where the distance between these two atoms is infinite. Means no force of attraction or repulsion is acting on them. When they start coming closer to each other, new attractive and repulsive force will start operate over there. Okay. And a state will come over there when they will be in the bonded state. Okay. If I talk you about the graph, it looks like this. Okay. This is your internuclear distance. See, here internuclear distance is minimum. This is your potential energy here. You can find out that the potential energy is minimum. See, when I have started this chapter, I said that why do elements combine with each other? I asked you this question and we discussed over there to attain the minimum energy or to attain the noble gas configurations. Okay, so out of these three scenarios, if I ask you which one is the most stable system, we will mark the point where potential energy is minimum. Minimum is the potential energy, higher will be the stability. Okay, and look at this. This is R, means internuclear distance. R, internuclear distance. Okay, and this is our bonded state. And this is your minimum potential energy. Minimum potential energy. Okay, so guys, this is the whole summary of the valence bond theory. Okay, first of all, I'm writing the important points of the valence bond theory. You have to copy those points, and after that, you have to draw these graphs. Okay, and one more important thing that you have to remember, that what type of bonds will be found over there. About that we will discuss about these important points. Okay, so guys, you can please copy with me, you can please copy along with me. Okay, after that you have to plot those graphs. Okay, you can start with me. Important points. It was introduced, and guys, if anyone has got any confusion or doubt, please you can ask me. Okay, Hitler and London. Need not to remember, but yeah, this is just for the information. Okay, now to form, these are the important points, to form a covalent bond overlapping occurs between half-filled valence shell orbital of two atoms. Number 3, resulting bond acquires a pair of electron with opposite spins to get stability. Number 4, orbitals come closer to each other from the direction in which overlapping is maximum. In which overlapping is maximum. Strength of bond depends on extent of overlapping, or we can say directly proportional. Is directly proportional to extent of overlapping. Quite important point. Next, as value of n increases, bond strength decreases. For example, in the overlapping of 1s 2p, stronger bond will be formed if I compare with 2s and 2p, 3s 3p. Okay. Guys, how this overlapping will take place, we'll discuss one by one. Okay. You have to remember these points. Number 7. We can say this is the A part and this is your B part. If n is same, in that case 2s 2p can say 2p 2p 2s 2p 2s 2s. Okay, these are some important points that you have to remember. Then number 7, types of bonds. Guys, there are 2 types of bonds will be formed. Sigma bond, represented by this one, and number 2, pi bond, represented like this. Okay. Please do copy it and confirm once after copying that. And after that, you can copy those diagrams. Copied. Okay, I'll give you 2 more minutes to copy this. Okay guys, now copy this one as well. You can start from here. This one and confirm. Done. Itanagar, have you copied that? Itanagar, are you still there? Are you done with that? Okay. Copy this one as well. Okay. Do this one, please. After copying that, confirm once. Okay. So guys, these are the main introduction, or we can say the theory of the valence bond. Okay. Now let's move on to the important section where we have to discuss about the sigma and the pi bonds. Okay. So the first bond is the sigma bond. Okay. First of all, let's write some important points regarding the sigma bonds. First is, it is formed by the overlapping of atomic orbitals along the internuclear axis. Okay. Internuclear axis means when they are parallel to their axis. I'll discuss about it when I'll draw the shapes for this one. Means how do they overlap? Okay. Internuclear axis means axis which is get passing through the nucleus. Okay. So this is the bond which is formed by the overlapping of atomic orbitals along their internuclear axis. Okay. Number 2. Sigma bond is directional in nature. Okay, directional means that obviously we are saying it will be formed when overlapping will take place along the internuclear axis, means all type of overlapping cannot result into formation of sigma bonds. Okay, only specified overlapping will result into formation of sigma bond. Okay. Now, next point, extent of overlapping is high. Therefore, it is a stronger bond. Or we can say the strong bond. Next. Free rotation is possible. Free rotation is possible about single sigma bond. Guys, please copy along with me. I hope so you are copying it. Next, sigma bond do not participate in resonance. Please copy. After copying that, please confirm once so that we can move to the section where we will learn by in how many ways a sigma bond can form. Okay. Any question for me? You want to ask me anything? Any query, anything which is not clear, or something that you want to ask? Okay guys, so let's continue. Formation. First, SS overlapping. See, this is your s orbital. This is also your s orbital. Definitely, the both carries the electrons. Okay. So, when they will overlap with each other, see, they will overlap like this. This is your sigma bond. Number 2, sp overlapping. First of all, look at the screen, guys. After that, I'll give you time to copy it. sp overlapping. This is your S. This is your P. Okay. One second. This is your P. So when they will overlap with each other, they will look like this. And this is your sigma bond. Okay. Now, look at this. PP overlapping. See, p orbital, p orbital. We are assuming it is parallel to the x-axis. Okay. So when they will overlap, after overlapping, they will look like this. See. So in these ways, p orbital can, sigma orbital can form. Please copy this. Once you have copied it, please confirm once after copying that. So let's start with the pi bond. Pi bond. Important points. First, it is formed by the sideways overlap. Means overlapping perpendicular, you can say overlapping of atomic orbital perpendicular to internuclear axis. Oh, hi Shillong. Now is it working? Yeah, actually I have seen you right now. Are you getting the telecast from the beginning of the class? Along the internuclear axis. This is the first point, guys. Number 2. No, Shillong, I cannot see you. I'm asking that, are you receiving the class from the beginning or you have just joined? Point number 2. Okay, that's cool. Any query or doubt? You can ask your query or doubt, okay? If you have any. If anything which is left, which is not copied by you, okay, that's cool. Okay. So, guys, you can copy along with me, okay? Number 2. Here, extent of overlapping is less. Therefore, it is a weak bond. Number 3. It participates in resonance. Pi bonds are less directional in nature. So, do not determine shape of a molecule. Next, pi bond will always be formed, or we can say it will exist with sigma bond. It has no its independent existence. Okay? It has no independent existence. Means if you say there is a 1 pi bond, it means there will be definitely one sigma bond. Okay? Pi bond will always exist with the sigma bond, whereas there is no such condition in case of sigma bond. Sigma bond has tendency to exist independently. Okay? So these are a few important points. Guys, please copy it and confirm once after copying that. Copy it. Okay. And guys, please mark your attendance. Shillong. And camera port as well. So that I can get you in the screen. Okay. Got it? Done? Anyone ask me any question, any query for me? Guys, remember in the NEET examination, chemical bonding is very important. Simple questions are asked from here. Okay? And I hope so everyone is getting this chapter. Okay, so guys, let's discuss how pi bond can exist, how it can form. Okay? Look at this. Formation. Guys, let's consider that x-axis is the internuclear axis. Okay? This is your x-axis, which is the internuclear axis. Okay? So all the orbitals which are perpendicular to the x-axis on overlapping will form the pi bond. See? This is p orbital, another p orbital. This is parallel to the y-axis. And this is also parallel to what? Y-axis. So when they will overlap with each other, after overlapping, they will form the pi bond. And they will look like this. One second. See. And this is represented like this. See, this is the shaded region. Means this is your bond region. This is also bond region. You can look it like this. Okay. These dots are the internuclear axis, and this is your overlapped region. Okay, so pi bond, oh, wow. My drawing, one second guys. Okay, so this is how the pi bond will look like during the overlapping section. Okay? Copy it and confirm once. Done? So guys, this is known as the pp overlapping, where one p orbital is overlapping with the another p orbital. Okay, this is first type. Number two, pd overlapping. Look at this. This is your p orbital, and this is your d orbital. When they will overlap with each other, after the overlapping, they will look like this. Okay, this is your PD overlapping. Next is your number 3, which is DD overlapping. See, so when they will overlap with each other, it will look like this. Okay, so guys, pi bond can be formed in 3 ways: by the PP overlapping, by the PD overlapping, and by the DD overlapping. Please copy it, confirm once. If you have any question or query, please ask me. Shilong, I think your camera is not working, dear. Copied? Shillong, Itanagar? Yeah, maybe. It's okay. No problem. Guys, have you copied it? Okay. Guys, let's take a 5 minutes of break. Okay. I'll see you in the 5 minutes. Hello guys, welcome back. Are you there guys? Shillong, Itanagar? Confirm once. Okay, Shillong, is that in total 13 students or in one section 13 students are there? Okay, in one section. And what about the other section? Dear, can you please share your attendance? Okay, you are sitting in the one class. Means in total there are 13 students present in Shillong today. Uh, okay. Can you please confirm once how many total students are there today in today's class? Total strength at your center, including both the sections. I think you both sit side by side. If you have any data. I was asking that can you please confirm what is the total strength today? Counting section A as well as section B. Total strength today. Okay, so in total there are 20 students, I think. 13 in your section and 7 in the other section. Am I right? Okay, that's cool. So guys, hi to everyone. Because we have just connected to each other. Okay. So guys, I hope so that the valence bond theory is clear to everyone till now, the topic we have discussed. Okay. Now guys, let's understand that how we can count the segment pi bonds. Okay. Hi. Okay. So guys, counting segment pi bond. Guys, I'll do 1 or 2 questions for you, then I'll give you 1, 2 questions. You will answer those. Okay. For example, I'm saying CH3, CH double bond, CH, C triple bond, CH. Guys, first of all, make it clear that whenever there is a single bonds means sigma bond. You can make note of this one. You can make note of this one. That whenever is single bond, I remove this atoms. Whenever there is a single bond, it is sigma. Whenever there is a double bond, there will be 1 sigma, 1 pi. Whenever there is triple bond, you will get 1 sigma and 2 pi. Okay? Single bond, sigma. Double bond, 1 sigma, 1 pi. Triple bond, 1 sigma, 2 pi. Okay, you have to remember this one. Now, just look at the structure. Guys, first of all, we need to expand this structure. Okay, draw its simplest form. So in the simplest form, this structure can look like this. Okay, I think so in the organic chemistry you have already learned about it, or you should have knowledge about this one, that I can write it like this in the expanded form. Okay, now we can count the bonds. See, between carbon and hydrogen, sigma, 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 pi, sigma, 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 2 pi, sigma. You can give a count to the sigma bonds. Okay, 4, 5, 6, 7, 8, 9, 10. So there are 10 sigma bonds. Count the pi bonds, 1 or 2, 3, 3 pi. So guys, this is how do we determine, or we can say count the sigma and pi bonds. Okay, let me take another example. For example, let's talk about the benzene. Benzene look like this. Draw its simplest form, where this will look like this. So we can count the sigma and pi bonds. Sigma, 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 sigma. Now, there are 3 pi bonds. Sigma, sigma pi, sigma, sigma pi, sigma, sigma pi. Okay, so guys, we can count the sigma and pi bonds. See, 6 and 6, 12. 12 sigma, 3 pi. Okay, this is in the benzene, that how do we calculate the sigma and pi bonds. Okay, so guys, please confirm once, is it clear to everyone that how we can calculate, how we can determine the sigma and pi bonds? Anyone has got any confusion? If not, please copy it and then I'll give you a question. Copy it, please. Okay, very good. This one, copy benzene. Okay guys, let's move on. This is the question for you. Count sigma and pi bond. CH2, CN whole twice. Okay, I hope so you can expand the structure. Okay, this is your first question. The second question is CH triple bond, C, CH double bond, CH, COOH. Do this question. At the Shillong Center, one student on my left hand side on the first bench is talking to the students. Hi. Please guys, answer this question. Okay. Who has got this answer? If all of you has got the same answer, you can please say all. Very good. Do the second one, please. Itanagar, have you got the answer? Is there anyone who has got some other answer as well? Can I start? Okay guys, so let's start. The first question was this one. Guys, I can expand that structure in this manner. Okay, let's count the segment pi bonds. Sigma, 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 2 pi, 2 pi, 4, 1, 5 and 6, 6 sigma plus 2, 4 pi, sorry. So congratulations to all of you who have got the right answer. Now let's take a look for the question number 2. Say triple bond C, CH double bond C, CH, CH, C, O, H. This is the expansion. Now let's take a look. Sigma, sigma, 2 pi, sigma, 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 pi, sigma, 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 pi, sigma, sigma. So let's count. 3, 4, 5 to 7, 8 to 10. 10 sigma plus 4 pi. So congratulations to all of you. You have got the right answer. Very good. Now guys, I'm giving you true false questions. Okay. Read that question very carefully and then answer me. Okay. Question is true or false. In a molecule, number of sigma bonds will always be greater than the pi bonds. This is the statement, guys. You have to tell me whether it will be true or false. In a molecule, number of sigma bonds will always be greater than the pi bonds. First of all, copy this question and then tell me your answer. Please take your time. I'm giving you 2 minutes to think about this question and then answer me. Itanagar, any confusion or doubt? Dear, is everything clear to you? Okay. Who has got this answer? Shillong? All. Can you give me any example where you can say that this statement will be discarded? Any example? In the alkynes, sigma bonds are equal to the pi bonds. That's what you are trying to say. Am I right? In the alkynes, sigma bonds are equal to pi bonds. Absolutely right. False. Can pi bonds be greater than sigma bonds? Can pi bonds be greater than sigma bonds? Can you please tell me any example? Itanagar, are you still connected to me? Shillong and Itanagar, can you give me any example where pi bonds are greater than a molecule where pi bonds are greater than sigma bonds? No, can I start? Guys, you can look at the CN, where only one sigma bond and two pi bonds. Yeah, exactly, cyanide. In the cyanide, sigma bonds are lesser than the pi bonds. Okay. So guys, remember, yes, there is a possibility where pi bonds can be greater than sigma bonds. They can be equal to. Okay. It won't be true that sigma bonds should also or should always be greater than the pi bonds in a given compounds. Okay. So any question or query for me? All clear? Can I move on? Okay, so guys, in the Westphal theory, we have learned that how bonds are forming over there. Okay, what are the necessary conditions to form a chemical bond? Okay, but still, guys, after discussing the two theories, we haven't got any idea regarding the shapes of the molecule. That how shapes of molecule or how molecules can look like. Okay, so guys, there is the next theory, which is your Vesper theory, VSEPR, Vesper theory. This is your valence shell electron pair repulsion theory. Guys, this theory gives the idea regarding the shapes of the covalent molecules. Okay. First of all, the important points. This theory gives the idea of shapes of covalent molecule. Guys, this theory has got certain postulates that we have to learn. Okay. Postulates are not so necessary for the examinations. Okay. But yeah, because this is, those postulates are the part of this theory. Okay. That's why we have to learn them. I'll discuss one by one the postulates, and after that we will learn how to draw the shapes. Okay. I'm sure after learning this theory, we are able to solve the questions based on the shapes. Okay. Please copy it, and then let's start with the postulates. Can I start? Okay. The first postulate, it says that the shape of the molecule depends on the electron pairs, which is bonded or non-bonded. Okay. These electron pairs surrounds the central element. Okay, in a molecule, central element which will be present at the center, and all the other electron pairs, whether they are in the bonded state or in the non-bonded state, will surround the central atom. Okay. Next, it says that the electron pair will tend to occupy such positions in space where between them there is less repulsion, or we can say the least repulsion. We know that electrons has got the negative charge. Okay. So in the space they will try to remain in such positions, or we can say at some bond angles where the repulsion between them is minimum. Okay. Next, if there is any lone pair, then that lone pair disturbs the regular geometry of the molecule. Okay. We'll discuss about the regular geometries. For example, we have planar, tetrahedral, tetragonal, bipyramidal, octahedral. These are the regular geometries, guys. Okay. So the regular geometry will be disturbed when there is a lone pair of electron. Okay. Last point, if we talk about the order of repulsion, then lone pair has got the maximum repulsion, then lone pair bond pair relatively less, and if we talk about the bond pairs, so between the bond pair there is the least repulsion. Okay, this is the order of repulsion. Okay, that we have to remember. So guys, let's write these postulates one by one. Okay, you can please copy along with me, and if you have got any confusion or doubt regarding any postulate, you can please ask me. Okay. Shape of a molecule depends upon electron pairs around the central atom. Next, electron pairs. One thing that you can write as well over here. Guys, please add this point as well. Bonded or non-bonded? Bonded or non-bonded? Around the central atom. the electron pair tends to stay as far as possible from each other. To minimize the repulsion. Okay. Number 3. The electron pairs which forms bonds are known as bond pairs. Whereas those who do not take part in bond formation are known as lone pairs. Lone pairs. Number 4, the presence of lone pair disturbs regular geometry of molecule. Next, order of repulsion. Lone pair, lone pair, lone pair, bond pair. Guys, LP means lone pair, BP means bond pair, and then least between bond pairs. Please copy and confirm. Guys, is there any postulate or any point which is not clear to you? You can ask me. Okay. Guys, I'm drawing a table for you. Okay. We have got 15 minutes. In that we will draw that table. Okay. First of all, just look at once that how I'm drawing it, and after that you will start copying it along with me. Okay. I'll discuss that how to use that that table next time. Okay. So please copy it along with me. And one thing that you have to remember, that size of the column, okay, size of the column. Guys, look at this. N by 2, where we have to write digits only, so you can make it as small as possible, means we have to write the digits. Hybridization. Need not to make this column very wide, okay, because we have to write SP, SP2, SP3D, so on, okay. Then arrangement of electron pairs. Around central atom. Here lone pair, here first write the bond pair, lone pair, and here we will get the shape. Guys, the column of shape and the arrangement of electron pair around the central atom should be wide, as wide as possible. Okay. Guys, first of all, let me draw one for you. After that, you will start copying. Look at this. For example, I say n by 2 is 2. Hybridization is sp. I'll tell you that how I'm writing the sp. Okay. Arrangement of electron pair will look like this. This is your central atom. These are the electron pairs. Okay. You will draw it like this. Bond pairs are 2, lone pair are 0. If this situation satisfies, then this one will look like this, AB. Okay. And this shape is known as linear. This shape is known as the linear. Okay. Next, 2 is over. Please copy it, and after that I'll start writing the rest. Done? Okay. Next. 3. Hybridization is sp2. Arrangement of atom around the central atom will be like this. Is your A. This one. Now there are two situations. First, bond pair 3, lone pair 0. If this situation satisfies, it will look like this. This is your planar. Okay. Or you can say triangular or trigonal planar. Triangular or trigonal planar. Triangular planar. Same situation, if bond pairs are 2 and lone pair are 1, in that scenario, you have to draw it like this. This is the lone pair, these are the bond pairs. And this shape is known as the bent, or also known as angular. Copy please. And guys, please draw the shapes neat and clean. In n by 2 equal to 3, we have two possibilities. In the next class, I'll tell you that how to use this table. Okay. Can I move on? Everybody done? Okay. N by 2, 4. Okay, okay. Do it. Guys, don't worry, please take your time. Okay, copy it clearly. Okay. And remember, you will definitely find one question in your examination from this section. Either that will be from the hybridization or from the shape. Every year we get question from this section. If you have got any confusion or any shape which is not clearly visible to you, you can please tell me. I'll redraw it. I'll draw it again. Okay, let's move on. This is your sp3 hybridization. If I talk about the arrangement of atom, then this one should be like this. 1, 2, 3, and then 4. Okay. Now there are 3 cases. First, bond pair 4, lone pair 0. If this happens, it will look like this. This is known as the tetrahedral. Next, bond pair 3, lone pair 1. If this happens, this is your pyramidal. Copy these 2 shapes first, after that I'll draw the next one in case n by 2 equal to 4. Copied. Okay. Let's move on. This is the next case where a bond pair are 2 and lone pair are also 2. In that case, this shape will look like this. See, for the simplicity, I'll draw it like this. No, you can draw it like this. Don't worry. This one. B. And this is known as the bent. Bent or angular, anything. Now, the next case. N by 2 equal to 4 is over. Now, next case, n by 2 equal to 5. In case of 5, hybridization will be sp3d. Arrangement of atom is like this. Okay. So the first case where bond pair are 5 and lone pair are 0, in that case it will look like this. Guys, do one thing, the bonds which are in green are bigger than the bonds which are in blue. Okay, the bonds which are in green are bigger than the bonds which are in blue. And this shape is known as the, where I can write, I'm writing over here, this is your trigonal bipyramidal. Trigonal, is it visible to you? I'll write it on the next page here. I'll write it on the next page. Please copy it once. Copy it. I'll write the name of the shape on the next page. Okay. This was your trigonal bipyramidal. Okay. Now the case number 2. 4, 1. In that case, it will look like this. B, 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 and B. This is known as the seesaw. Okay. This is your seesaw. 3, 2. 1, 2, 3. Two lone pairs, and this is known as your T shape. T shape. Copy and confirm once after copying that. Guys, shapes are clearly visible to you. If you have any confusion in any shape, you can please tell me. I'll redraw it. Copied. Next case, 2, 3. It is like this. And this is known as the linear. Okay. Copy, please. That's all about your n by 2 equal to 5. Now let's move on to n by 2 equal to 6. 6. This is your sp3d 2. Arrangement of atoms are like this. This is your central atom. Case 1, 6 and 0, and in that case it will look like this. And this shape is known as the octahedral. Okay, this shape is known as the octahedral. Hedral. I'll write it on the next page. Copy it once. Done? Okay. Octahedral. Now let's talk about the second case. 5, 1. Copy it. This is your square pyramidal. Square pyramidal. 4, 2. A. This is your square planar. We have got last shape, guys. After that, we will wind up this one, and in the next class, I'll tell you that how to draw the shapes, how to use this table. Okay? Copy and confirm once. Copied? Okay. Last one. 7. This is your sp3, d3. Okay. I'm drawing its shape directly because there is only one case. Bond pair 7, lone pair 0. And it actually look like this. Guys, this is your pentagon. And these are the perpendicular bonds. Okay. And the shape is your pentagonal bipyramidal. Pentagonal bipyramidal. The example known for this one is IF7. I'll discuss about it. Done? Okay, cool. So guys, let's continue this topic in the next class. Okay. So guys, till then, take care. Bye bye. Please stay healthy. Take care of yourself. See you next time.